Okay, this is a small uh, detour into talking about a couple of transmission systems. And first, we are going to talk about gears. Next, we will talk about belt drives and chain drives. So so what are gears? You all know what gears are in some sense. Let me just draw a very rough picture of what gears look like. This is not meant to be particularly precise or accurate. So imagine one gear like so, and another gear like so. And I haven't quite drawn the teeth of the gears, so let me draw them like so, maybe a lighter color. Um, so I'm just drawing the teeth very roughly. Obviously, gear teeth don't quite look like that. They are more precise and they're of a particular shape, but I'm just drawing something to give a general sense of what gears look like. Okay, so those are two gears, and let's say um, the radius of gear 1 is R1, and the radius of gear 2 is R2. And let's say the midpoint of the center of gear 1 is O1. Let's say the center of gear 2 is O2. Um, let's label these things gear 1, gear 2. Um, let me redraw the gears, but without drawing all the teeth so that the picture is a bit clearer. So I'm just redrawing essentially the same thing, but without the gear teeth. So that's gear 1, and then that's gear 2, and everything is the same. I'm going to call this R1, and this thing is R2, the radius. This point is O2, this point is O1. And let's say the angular velocity of this gear is omega 1, the angular velocity of this gear is omega 2. Now, of course, that you sort of intuitively feel like if this gear rotates with omega 1 this way, this gear would rotate this way. But what we are defining here is just a sign convention, it's just defining notation. And later on, we will find that omega 2 and omega 1 are related in the manner that they are in opposite directions. In other words, there's a negative sign that will show up. Okay, so now let me define a couple of more points. So like we said, um, this point is O2, this point is O1, the center points. Let me also define points. So let me use a different color. Maybe I'll use this color again. Let me use this color to define this point P1 and this point P2, where P1 and P2 are points on gears 1 and 2. That contact each other. In other words, P1 and P2 are in contact. P1 is a point on gear 1 and P2 is a point on gear 2. So they are the contact points. Okay. I've given them different notation, P1 and P2, rather than calling at P because there are 2 points, one on P1, one on gear 1 and one on gear 2. Okay, let's introduce a couple of more notations, the usual ones. Let's call this I, let's call this J. Anything else? I guess that's all we want for a moment. Now, what is the typical situation in which these gears operate? We can say that points O1 and O2 are at rest. In other words, this gear rotates about this point, this gear rotates about this point instantaneously. So velocity of O1 equals 0, velocity of O2 equals 0. That's typically, so this is not quite a problem, this is more of a discussion of how gears work, right? In other words, O1 and O2 are fixed in space, let's say. And then we can ask, what is the relation between omega 1 and omega 2? Okay, what is the relationship between omega 1 and omega 2 given all this stuff? What is it? Okay, so the main point is that the gears do not slip against each other. So if the gears do not slip against each other, what does that mean? Essentially, it means that the contact points, whatever 2 points contact each other, they're going at the same velocity. Okay, that's what we mean by no slip. No slip means the 2 points that are in contact with each other are going at the same velocity. It's not like they have zero velocity, but they're going at the same velocity. If this point P1 goes at some velocity, this point P2 goes at the exact same velocity, so that there is no relative motion between the two, and that's relative motion is what we call slip. So no slip implies VP1 equals VP2. Okay, so what is VP1? VP1, well, you can either do it quickly just by looking at things, or you can use the formulas we've been using over and over again. VP1, which is the velocity of this point, it's on this rigid body, the gear. This rigid body has this point at rest, and this point, this is angular velocity omega 1. This is radius r. So it's going to be r times omega 1, r1 times omega 1, and it's going to be in the vertical direction. Okay, so you can write, just based on that reasoning, we can write VP1 equals r1 omega 1 j. If you want to sort of do that slowly, we can say VP1 equals, this is the rationale, VO1 plus, right? So P1 is on this rigid body. We know the velocity of O1. We know the angular velocity, let's say. Angular velocity, or at least you can write it in terms of the angular velocity, omega 1k cross r P1 with respect to O1. What is r P1 with respect to O1? That's R1I. So we can plug everything in here. This is equal to 0 because the velocity of O1 is 0, plus omega 1k crossed with R1I. And if you expand that out, you get 0, of course, which you ignore, R1 omega 1. K cross I is J. Okay, so this is the reasoning to get this. Let's call that equation 1. Well, actually, let's call this equation 1, no slip. Let's call this equation 2. Similarly, we can compute what VP2 is. VP2. In this case, let me just again let's do it the quick way and then the slow way. We said it's angular velocity is omega 2 anti-clockwise. Velocity of this point is going to be r2 omega 2 and in this direction. So you can just either say that directly in the minus j direction, right? So that's going to be equal to minus r2 omega 2j. Or so you can call that VP2 equals minus r2 omega 2j. Call that equation 3. So this, by the way, was reason for 3. So reason for 2. Similarly, you can write down the reason for 3. You can do that slowly. VP2 equals VO2 plus omega 2k cross R P2 with respect to O2, which gives us 0 because velocity of O2 is 0 plus omega 2k crossed with, what is P2 with respect to O2? P2 is this point, O2 this point. This vector is minus R2I. And then if you do the cross product, you get omega 2 R2 k cross I is, so you already have a negative sign, and then k cross I is j. So you get minus R2 omega 2j. That's VP2. Okay, anyway, that was just a careful derivation of these two equations, which we wrote down by inspection. So let's plug in this expression and this expression into equation number 1. What do we get? We get R1 omega 1j equals minus R2 omega 2j. You can sort of cancel the j's. And what we get is omega 1 by omega 2 equals minus R2 by R1. So this is the speed ratio. And this is on the right hand side is the ratio of the radii. And this is also equal to what's called the gear ratio. Okay. So what does this mean? It means if one of the gears go at a particular omega 1, the other thing goes at a different omega 2, and the ratio of those omegas depend on the ratio of the radii. If the two gears have identical radii, then they will go at identical speeds, but bigger the radius, smaller the angular velocity. While angular velocity is smaller because the linear velocity of this point is matched, right? So that's what we've used here. We've used the fact that at this point, the linear velocity is matched, which means that the angular velocities are inversely proportional to the radii. So that's essentially the fundamental principle of gears. They allow you to increase or decrease the angular velocity of let's say there's an axle here, an axle here, and you get to if this is the input and this is the output, you can decrease the angular velocity by increasing the radius, or you can increase the angular velocity by decreasing the radius. Okay, so that's the kinematics of gears. So that this is the key relationship. A sort of a consequence of the speed ratio relationship is you can differentiate it once more, and the angular accelerations obey the same relationship, like so. Okay, this implies that.